Hey everyone, and welcome to this video on introducing static and kinetic friction. So friction is a resistive force that opposes sliding motion between two contacting surfaces. It arises due to the imperfections between the two surfaces of the objects. So essentially, the rougher the surface is, the more imperfections there are, and the more friction you're going to get when you're sliding or when you're trying to move something. So there's two main types of friction that we're going to go over in this course. There's static friction and kinetic friction. So static friction is the friction that stops an object or prevents an object from sliding in the first place. It essentially pushes back when another force is trying to move it. And it's a variable force, meaning the more you try to push an object, the more static friction it's going to push back. But it has a range. So if nothing's trying to push an object, there is no static friction on it. So the static friction would be zero. But if you push hard enough, then you're going to exceed the maximum static friction force and the object should start sliding. So the range that it has is that the static friction is somewhere between 0 and the max value. Kinetic friction is a little bit simpler. It's also called sliding friction, and it just acts in the opposite direction of sliding motion. And it doesn't have the same range property that static friction does. Instead, it's just an equation where once you find out the value between two surfaces, the kinetic friction is just that value. So the equation for the kinetic friction is the magnitude of the kinetic friction force is the coefficient of kinetic friction multiplied by the normal force. The equation for the static friction force is a little bit more complicated, but it's essentially the same thing. Where because static friction has that range property where it can change between 0 and its maximum value, the magnitude of the static friction force is less than or equal to the coefficient times the normal force. But if you wanted to use the same equation as the kinetic and just multiply the coefficient times the normal, that would actually give you the maximum value that the static friction can be for a given pair of surfaces. So one of the things that we haven't really addressed, but we've been throwing out in the equations, is this term called the coefficient of friction. It's symbolized by the Greek letter mu, which is like a U with another tail in the front. And it's a unitless number, meaning it doesn't have units like meters or newtons or anything like that. And it tells how much the two surfaces are going to interact while they're in contact with each other. Loosely or casually, it's a gauge of how rough or smooth the two surfaces are. The rougher the two surfaces, the higher the mu value, the more friction. The smoother the two surfaces, the lower the mu value and the less friction. So you'll notice here that the normal force shows up in the equation for both static and kinetic friction. And the normal force is a force perpendicular to a surface, whereas the friction force is a force parallel to the surface. So why is it that this is showing up in our equation when they're in different directions? It's because the normal force gives us a gauge of how pressed together the two surfaces are. It tells us how much in contact surface 1 is with surface 2. So the greater the normal force, the closer and the more pressed together the two surfaces are, which is going to result in more friction between the two surfaces. The lower the normal force, the opposite is true. They're not in contact as much, and therefore there won't be as much friction between the two surfaces. And that's it on this video introducing static and kinetic friction. Thanks for tuning in, and I look forward to seeing you next time.